Great. So this talk is all about GRANDstack, which we will be talking about in depth. The slides you can get at bit.ly/GRANDstack. They're just Google Slides. And my Twitter and website are up there. Feel free to reach out to me. Cool. So if you don't know me, my name's Will. I work at Neo4j. I work on the Neo4j Labs team at Neo4j. So we don't work on the core database in Neo4j Labs. We work on tools, extensions, things around the database. If you saw the keynote this morning, Michael talked a bit about Neo4j Labs and some of the projects that we work on. And GRANDstack and our GraphQL integration is one of those projects, which is what I work on. So in the next 30 minutes or so, what are we going to talk about? Well, we'll have sort of an overview of what is GRANDstack, what are we talking about when we talk about this, and then we're going to jump into building a Nodes 2019 conference recommendations app. We'll see this, and then we have some Hunger Games questions to jump into. If you're not familiar with Hunger Games, basically the idea here is we have some questions at the end of each of these sessions at the conference, just to sort of make sure that everyone is interested and following along. So this one should be fun. Cool, so I'm just gonna jump over into the chat here to make sure there's no issues. Looks like no one's complaining, so cool. Okay, so when we say GRANDstack, what are we talking about here? So what is GRANDstack? Well, the idea here, GRANDstack is a full stack framework for building applications. So the individual components of GRANDstack are GraphQL, React, Apollo, and the Neo4j Database. So GraphQL, this is our API layer. React is a JavaScript UI library for creating user interfaces, both on web, mobile, now in VR as well. And Apollo is a suite of tools that make it easier to use GraphQL both on the client and the server. And then Neo4j Database is a native graph database. And this is our Nodes conference, so we won't talk too much detail about Neo4j. Hopefully you're a bit familiar with that at this point. So if you're not familiar with GraphQL, what is GraphQL? Well, GraphQL is an API query language. That's an important distinction that we're talking about querying an API, and a runtime for building APIs. So with GraphQL, we have a type system. We describe the data that's available in our API. The client asks for only the data relevant for that request, and the data comes back in the same shape as the query. So get exactly what the client asked for, nothing more. So it's basically, we're talking about efficient data fetching. GraphQL makes a really, really important observation though, that your application data is a graph. So regardless of how you're storing it on the back end, if it's in a document database, if it's a relational database, a graph database, that's still presented to the consumer of your API as a graph. And this is really, really interesting and exciting for the Neo4j and the graph database community, because that means there's a one-to-one mapping between the data model presented in the API layer to the database all the way in the back end. So if you watched the keynote this morning, Emil was talking about this idea of graphs all the way through the stack as part of GRANDstack, and that I think is really an exciting piece here. So the goal of our GRANDstack and GraphQL Neo4j integrations is basically to make it really, really easy to expose a GraphQL API from Neo4j. So we do this by allowing GraphQL type definitions to drive the database data model. We auto-generate a GraphQL CRUD API from those type definitions. We do what's called auto-generation of resolvers. This is the boilerplate data fetching code that you don't have to write, that our integration takes care of. And we can also go the other way. So if you have an existing Neo4j database, we can infer a GraphQL schema from that existing Neo4j database and give you a full CRUD GraphQL API on top of Neo4j without writing hardly any code. So that is what the heart of GRANDstack and GraphQL Neo4j is all about. So grandstack.io, there'll be a few pointers to that site. That's sort of the main site that has documentation, tutorial videos, starter project. There's a GRANDstack blog. So in general, if you're looking for resources on how to get started with GRANDstack, grandstack.io is the place to go. So this morning, as we were getting ready for the Nodes conference, I realized that we needed a Nodes session recommender web application. So I had a little bit of free time this morning. I wasn't quite done preparing this talk yet, so I thought it would be fun to try to put this together. And I sort of huddled in a conference room at the office for a little bit this morning, and this is what I came up with. So it's not perfect, but the basic idea is here. So these are all of the sessions that we are presenting today at Nodes. It's kind of neat to scroll through this and see how many there are. And what I wanted to do was make it easy to not only show you what sessions are available, but make it easy to search for sessions that you might be interested in. So we're in this GRANDstack session, so let's search for all of the GRANDstack talks. Okay, so what this is doing is filtering for talks that have GRANDstack in the description. So there's maybe 7 here. And that's cool. So now I know, okay, these are the talks I want to go to. But one thing that a graph database is really, really good at that you're probably familiar with is this idea of personalized recommendations. So in a graph, it's pretty easy to represent this idea of, okay, so I'm interested in this item, in this case, a conference talk. What are some similar conference talks, either based on content or based on user interaction? That's called collaborative filtering. So I wanted to add some recommendation feature. So here we have recommended talks. So if I've attended the Discovering the Soul of a Product with Neo4j, where Pat Brown talks about how they use GRANDstack at Under Armour, here's a good recommendation for me for another talk that I might be interested in. So that's great. That's personalized content that's relevant for me. And this app is live, so it's Nodes 2019-app.grandstack.io. So as you're preparing your schedule for the day, feel free to go through this. If you're interested in algorithms, here's all of the algorithm related talks, and we can generate personalized recommendations for each one. So that's neat. So as I was putting this together, I was kind of reflecting back on sort of the evolution of web development. And last week in the office, I was talking with some coworkers about what we were all doing and working on in the mid-90s. And without sort of dating ourselves here, I guess with dating myself in this case, in the mid-90s, I was the assistant webmaster at Naples Elementary School. So I maintained, I guess, what would be the equivalent of a blog. So I wrote these static HTML pages with images, basically about field trips that we went on to cheese factories and things like that. And this was my first exposure, of course, to the web. Everything was still pretty new at that point. For dynamic content, we had this idea of CGI, where basically we said, okay, there's a certain directory, and in those directories we have executable scripts that run on the server that maybe fetch data from a database and give me dynamic content. So I'm able to now embed database queries in this sort of template language along with my static HTML and whatnot. And this became essentially the LAMP stack. So Linux, Apache, MySQL, PHP, and this was very, very, very popular initially because it became really, really easy to fetch data from a database dynamically and render simple views, right? So that's what we wanted at that time. Then later on, we realized, well, okay, we're embedding database queries in some templating language. That's kind of ugly and hard to maintain. We need a better representation of this. We need sort of this intermediate layer. So this is when REST APIs and JSON became popular at the same time. jQuery became sort of a a glue way on the front end to do AJAX to fetch data from a REST API and render that on the front end. So the first job that I actually was paid at to do web development was using jQuery for my assistant webmaster job. I think I was just paid an ice cream. Then later on, we saw the need for these web scale databases. So we saw NoSQL, the mean stack emerged. So that's Mongo, Express, Angular, Node.js. And this became very, very popular because it became very, very easy to basically map documents in a document database to REST APIs. We started to see these front-end frameworks like Angular that made it more easy for us to encapsulate logic and UI. We saw things like Meteor that were really pushing the edge of what was possible at that time with web development, giving us near real-time streaming content, things like this. And that brings us to roughly the present day, maybe a few years ago. And on the front end side, with things like React, which was open sourced in 2013 by Facebook, we saw the goal of taking the mental model of sort of how we thought about server side to JavaScript on the client. So this is basically moving from where we might have event listeners to now talking about actions that we wanted to take against state. So things like the virtual DOM also gave us performance improvements. Instead of rendering our entire view, let's just render what the minimum amount that we need that has changed based on the change in state. So not only is this giving us components to encapsulate logic and UI, it's now giving us performance optimizations around that. Shortly after that, GraphQL was also open sourced by Facebook. And GraphQL, again, this is all about efficient data fetching, giving us a type system for our data that allows us to describe and query our API as a graph. Now, about the same time, we saw the rise of graph databases like Neo4j as the move from other forms of NoSQL became problematic. As we saw data become more complex, we had different types of data. The intuitive graph data model with graph databases was very appealing for developers, and we started to see a very different performance characteristic with graph databases, which are optimized for traversing a graph very, very efficiently. Now combine that with some of the serverless and deployment options we're seeing today, basically really, really nice developer experience over cloud services. So I'm thinking of things like ZiteNow and Netlify that make it really, really easy to deploy front-end and back-end code together with a simple command line tool. Behind the scenes, they're taking care of deploying things to Lambdas on AWS and things like this. But as a developer, I don't want to think about that. I just want to deploy my application code. So looking back, sort of the evolution of web development, I think we're really actually very, very fortunate to be where we are now and have these technologies to work with. So as I said earlier, a really, really interesting observation here is if we look at some of these technologies that have been emerging, there's a lot of graphiness going on here, right? With GraphQL, we're talking about exposing our API as a graph. In a graph database, we're talking about actually storing data in our database using this graph data model. And this is why I'm so excited for GRANDstack, because we're working with graphs all the way down. We can leverage the performance optimizations and sort of intuitiveness throughout the stack. Okay, so that's sort of my my aside, thinking about the evolution of the technologies I've worked with as I was considering building this conference app. How do we actually do that? Well, if you've ever been to a Neo4j conference before, you know that we always put together the conference graph. So oftentimes, instead of looking at a tabular representation of the schedule for the day, it can be a lot nicer to look at a graph representation. It's also a great way to get our hands on some actual graph data. So I've set up a Neo4j Database as a Service instance. So if you were in the keynote, you heard Emil talk about the new Neo4j Database as a Service. I have had early access to that, so I've configured an instance here with the data. Feel free to log into that. There's a read-only user with a name, username nodes and password nodes. Don't worry, you're not going to break anything, so feel free to query away. So if you're not familiar with Neo4j, this is Neo4j browser. And I'm just going to jump into the chat here, maybe just again to make sure there's no problems here. So hi, everyone. Yep, looks like we're good there. Great. So this is Neo4j browser. This is a query workbench for Neo4j. So I can write Cypher queries. So call db.schema gives me sort of the data model view. So what sort of data do I have? So I have speaker nodes that are connected to sessions. Sessions have a subject and a tag. They're in a venue. Since this is an online conference, the venues are tracks here. And then a speaker works for a company. So I can write Cypher queries. So I can say, I don't know, let's find myself here. Let's actually look for speaker where s.name contains well and return the speaker. So this is Cypher. If you haven't seen it before, the query language for Neo4j. Think of it as like SQL but for graphs. So we're sort of defining this ASCII art syntax here. So there's actually a few wills. So we'll just limit this down to me. And we describe patterns here. So I'm interested in the sessions that Will is presenting. And let's return everything here. I can see, okay, great. So I'm presenting 2 sessions. This is the GRANDstack talk, which we're in now. We can traverse out and see the track and the tags. And then later on today, I'm presenting another session on leveraging graph algorithms in visualizations with NeoVis. So what do these have in common? They both have JavaScript and they both have me in common. Cool. And of course, I can traverse out and see, okay, well, what are the other GRANDstack talks that we have in the conference and so on. So that's the data model that we're using for this conference app. It's a little bit of a view of Cypher and how to query it. The next step for building this conference app is that we want to build our GraphQL API because our front end is going to query that. And so before we go too deep into how we build the GraphQL API, I just want to go into a little bit more detail about GraphQL. So let's imagine that we have some data about movies and genres and actors. So the first thing that we do is define some type definitions. We do this using the schema definition language for GraphQL. Once we've done that and deployed and sort of spun up our GraphQL API, there's a really, really powerful feature in GraphQL called introspection. And what this means is that our GraphQL service can be queried. And what that means is that the schema then becomes our API specification and documentation. So we can use tools like Graphical and GraphQL Playground to explore that, essentially making this sort of a self-documenting, self-exploring, at least, API. So here's a GraphQL query. The GraphQL query has a few components. One is the operation name and arguments. So here we're saying find movies with the title A River Runs Through It. And then the rest of this query is the selection set. So the selection set is essentially saying, okay, there's a lot of data that we've defined connected to movies in our type definitions that defines this data graph. But I only want to traverse the graph a certain way and only return certain fields. So that's what our selection set does, is it specifies how we want to traverse through that graph and what fields we want to return. Note that our nested selections can also have arguments as well. So here we're doing only giving the first 2 actors connected to A River Runs Through It. But note we're traversing a couple hops down. So we go from the movie A River Runs Through It, in this case to its directors, then from those directors, all of the movies connected to those directors, and then give me the title. So what we're describing is a graph traversal, and this is the data that comes back, right? So we get our movie, a river runs through it, the actors, the directors, and all the movies connected to the directors, which in this case is just Robert Redford. So it's important to understand that GraphQL is a API query language, not a database query language. So we have limited expressivity. We don't have the ability to do projections, aggregations, things like this. And it's important to point out that GraphQL does expose your application data as a graph, but it's not just for graph databases. We can use essentially any data layer with GraphQL. We'll see how we can implement that in a second here. So some advantages of GraphQL. Well, we talked about efficient data fetching. And when we say efficient data fetching, what we mean is we're not going to be overfetching, which is requesting more data from the back end than what we need and sending that over the wire. If you think of REST, if I request a user object, I get back a user object in every field on that. With GraphQL, we only get back the piece of the user object they were interested in. If we're only rendering a few fields in our view, that's all that we should fetch from the back end, because that may be expensive to fetch some of those fields, and that's less data sent over the wire, and especially dealing with mobile networks and things like this more and more, it's important to optimize that. And then underfetching is another problem that GraphQL solves. This is the idea of sending all of the data needed to render a view in a single request. So with REST, oftentimes if I fetch a list of things, maybe a list of blog posts, and then I need the author for each one, I may have to make another request for each author to get more information. With GraphQL, I can say, give me all of the posts and all of the author information in one request. There's this concept of graphs all the way down. Now, in this case, what I mean is from the front-end framework to the API, which basically allows us to have more component-based data interactions. And also when we're interacting with our API, we typically are doing this in the context of relationships, not resources. So show me a list of blog posts and the connections to them rather than iterating through a list of resources, right? Now, all of these advantages don't come for free, of course. There's always trade-offs. There are some challenges with GraphQL. So one of these is that some well-understood practices from REST don't really apply here. Things like HTTP status codes, errors, caching. There are ways to handle these things in GraphQL, and the GraphQL community, I think, has really pushed forward a lot of this, but they may not be the ways that you're used to when you first come from sort of a REST world. Now, there's also this idea, okay, if my client can request an arbitrarily complex query, am I not going to have performance considerations there if I can't control that? So this is one challenge. There's a solution to this. We can essentially restrict and define in advance the queries or the depth of a query that a client is able to request. Then we have things like, how do we do rate limiting? How do we do query costing? Because the request that comes in is not necessarily just requesting one resource. So we have a bit more work to do. But again, there are solutions for these. Okay, so how do we build a GraphQL service? Well, basically, the high-level approach here is we take our type definitions and we implement resolvers. And the resolvers, these are the functions that define how to fetch data for a GraphQL request. So in these, we may have to do some authorization validation. We may have to query a database. We may have to validate and format that response, and then we send some data back. And we end up writing a lot of boilerplate in our resolvers, which is not so much fun. So the problems with what I'll call the standard approach, where we write some type definitions and we implement some resolvers with data fetching code, is we end up with schema duplication. So both our API and our database are maintaining a schema. And we often have this mapping and translation layer from GraphQL to whatever our backend layer is. If it's another API, if it's a document database, relational database, there's this mapping and translation layer where we're defining our data fetching code. And there's a lot of boilerplate when we write that, right? So if we look back here, This is, getting a session from a database driver instance, executing a query, iterating through the results, reformatting that. So not ideal. And then we also have this n+1 query problem. So we may, from the back end now, have the same problem where we have to fetch a list of things, and then we see that, oh, we've requested a connected field, so we have to iterate back to the database. We want to be sure to only make as few requests to the database as needed. So there's a class of tools called GraphQL engines that have come out to address some of these issues. Here's some examples. A lot of these are built on top of Postgres, or in the case of AWS AppSync, exposing AWS resources with GraphQL. But what I want to talk about is the Neo4j GraphQL integrations. So the goals for these integrations are to take still a GraphQL first development approach, where we're generating Cypher from GraphQL. We're using the GraphQL schema to drive the database model and take care of that boilerplate code. And then we also want to sort of extend the functionality of GraphQL. As we said, GraphQL is for querying an API, not a database. So we need to expose some more custom logic there to handle those cases that are just beyond simply CRUD. So first of all, GraphQL first development. So when we talk about GraphQL first development, what we mean is that the GraphQL schema becomes the driver of our API, of how we implement front-end data fetching code, and also, in our case, the data model and data fetching code for the database. Now, because there's this very close mapping from GraphQL type definitions to the property graph model in Neo4j, this is pretty easy to do with a graph database. Then we take those type definitions and auto-generate a GraphQL CRUD API. So we haven't talked about this in too much detail, but basically we generate what are called query and mutation types. So these are the entry points for the API, both for reads and write operations. Then we add a bunch of convenience things like ordering, pagination, filtering, working with the date time, database types, things like this. Now, this is a big important piece of this integration, is basically taking GraphQL, translating this to Cypher, and optimizing that generated Cypher query for one single round trip to the database. So that solves this n+1 query problem. And the next piece is extending the functionality of GraphQL with Cypher. And to do that, we've added this Cypher GraphQL schema directive. What this does is it allows us to bind a Cypher query to a field in our GraphQL schema. So this becomes essentially a computed field that attached Cypher query runs as a subquery in the overall generated Cypher query. So it's still just one trip to the database. If you're not familiar with schema directives in GraphQL, they are essentially GraphQL's built-in extension mechanism to define custom server-side behavior. So our GraphQL integration, there's a few versions. There's one that's a database plugin that's useful for local development and testing, but the one I want to talk about today is Neo4j GraphQL JS, which is published as a Node.js package and is used with other JavaScript GraphQL tooling, so things like Apollo Server, GraphQL JS. So important to point out here, we're talking about making it easy to build an API application that sits between the client and the database. So we're not sending GraphQL directly to the database, but we're still building this API layer that, but we're just doing it in a way that makes it useful and easier to create GraphQL APIs. Okay, so this is scheduled to be a 30-minute session, but since these sessions are kind of individual, I'm just going to go ahead and kind of show the demo and press on here. If you want to drop off, feel free The video, yep, will be posted to YouTube. So feel free to drop off if you need to. Let's take a look at now some code here. So we talked about, we have our database here with our speaker information from the Nodes conference, and what we want to do is build our GraphQL API. So let's jump over, take a look at some code. So this is the code for both the front end and the back end. Let me make the text a little bigger. Both the front end and the back end for that Nodes conference recommendation app that we showed. We're still working on the back end here. So let's take a look at the API GraphQL schema. We want the schema.graphql. So these are our GraphQL type definitions. And in this case, these were auto-generated from an existing Neo4j database. So I just pointed our Neo4j GraphQL JS integration at my Neo4j database as a service instance, and I said generate type definitions for that data model. And we can see here, basically, the way this works is we have a type that maps to a node label, and we have fields that represent and map to properties on the node, and relationships are represented as essentially lists of object types. Now we have to add some metadata, in this case, a @relation directive where we can capture the relationship type, so works for, and then the direction, since we have directed relationships in the property graph model, but not in GraphQL. And one other important thing I want to point out here is this field. So this is the recommended field on the session type, and it's defined. It resolves to a list of other sessions, and here we're using a cipher directive to define the data for this field. So if you're familiar with Cipher, you should be able to see what's going on here. We're starting from this, so that's a keyword to represent the session we're currently looking at. And then we traverse to find other sessions that have an overlapping tag or subject. We group by that recommended session. So for all of the other sessions that have an overlapping tag or subject, we take a count, and that becomes the score for our recommendation. So this is how we're finding other similar sessions to recommend. And that's essentially all the code that we're writing. The other bits here are pretty standard. We're using Apollo server, which is a wrapper on top of Express in this case that makes it really easy to spin up a GraphQL server on top of Express. If you're not familiar with Express, it's a Node.js web server. Here's where we are pulling in our Neo4j GraphQL JS, in this case, the make augmented schema export. If I didn't say it yet, this is Node.js JavaScript code. So this is the code that's defining our GraphQL server on the back end. And basically, we just pass those type definitions to make augmented schema from our JavaScript integration, and we get back a GraphQL schema object, which we can then, along with a Neo4j driver instance, pass into our Apollo server constructor to serve our GraphQL endpoint. So just kind of standard code there to get our GraphQL server running. And we can then check to make sure that it's running. So here's our GraphQL server. We can run a fairly complex query here. So one thing that we're seeing here in this query, so this is a GraphQL query. This is GraphQL Playground, which is kind of the query workbench. So let's think of sort of the equivalent of Neo4j browser, but for GraphQL. We can explore the docs, so we can explore the types that we have available, which is quite nice. And in our query, here we're just using some variables. So this is the query that our front-end application, the React application is sending. So of course it uses GraphQL variables. We don't want to be constructing those strings on the front end. We just want to pass in an object of values based on whatever our user's searching for. So we're searching for sessions and grabbing a bunch of fields. Now note here, event ended. So this is a field on session. This is a date time type. So which is an object type in our GraphQL integration. And here we're grabbing the formatted field, but we could also grab things like the individual date components of that. So give me the hour and day instead of this formatted field. So these are just some of the convenience functions that exist on top of our integration. And all of this data fetching code, so we're fetching data from that Neo4j Cloud instance in this case. So what's going on, if we jump back now to our backend code and jump into this terminal, what we're seeing here is the debug output, and what we're seeing here is the generated Cypher query from that GraphQL request. So we didn't really have to write any data fetching code. All we had to do was define our GraphQL schema, which is pretty neat. That's pretty powerful, a pretty powerful way to get an API up from just GraphQL type definitions. We didn't need to start with an existing database. We could have just defined those type definitions by hand, and then we would have had what are called GraphQL mutations generated, which allow us to create and add data in the database. Now, this was just a fork of the GRANDstack starter project, which is on GitHub. So to create this, all I did was fork this project, and I had both backend and front-end code to work with. And essentially all I did was change the GraphQL schema definition and some front-end code to get this working. So we said earlier that these GraphQL engines are these declarative database integrations for GraphQL that do things like allow us to either infer or to drive a database from GraphQL type definitions, giving us this auto-generated GraphQL API on top of our database and auto-generate data fetching code, which is really nice and convenient. You may be curious, okay, how do these GraphQL engines work under the hood? So before, when we were talking about our GraphQL resolvers, we said inside the resolver, we define some data fetching code. Maybe we do some authorization validation, things like that. Now, the resolver is passed some arguments, and one of those is the resolve info argument. And inside this resolve info argument, we have things like the GraphQL query AST, that's the abstract syntax tree. We have a representation of the GraphQL schema, so we can find the selection set in a nested fashion, what variables were passed in. And essentially what we do is we traverse that AST to find the nested selection set. So what are all of the fields that are requested? And we use that to generate one single database query. So you don't need to understand how that works to use our GraphQL integrations, but if you're curious, I am giving a talk at GraphQL Summit in San Francisco in a few weeks. So if you're coming to GraphQL Summit, I'll be there. Neo4j will have a booth there as well, so feel free to drop by and say hi. And I'm giving a talk about the resolve info object. So a lot of it is under the hood, kind of advanced talk of how we've built this GraphQL integration and how you can leverage this resolve info object to generate more efficient data fetching code in GraphQL. So that should be fun. Okay, so the code for this demo is online on my GitHub page. So feel free to play around with that. Again, I use this just starting from the GRANDstack starter project. GitHub has this really nice feature to treat repositories as templates. So if you just click use this template, it does something kind of similar to a fork. It gives you your own repository using the GRANDstack starter. So again, that is an example for both the API, the UI. There's Docker Compose for fetching Neo4j as well. Or you can run Neo4j locally, however you want. But that's really convenient for getting started. So what I want to do next is talk a little bit about some folks that are using GRANDstack and Neo4j GraphQL, and then point to some resources. So the three sort of examples I want to talk about are, first of all, Neo4j. So how are we using GRANDstack and Neo4j internally? Well, if you've ever used the community site, so this is community.neo4j.com, you've probably seen these activity feeds at the top of the page. So every week we have This Week in Neo4j, where we feature a community member. We have links to other resources. And then we also have these activity feeds where we're showing popular community content, community projects, so things from GitHub that people are working on. And the way that we fetch all of this is from a Neo4j database. We call it Community Graph, which has information about the community, what they're working on, GitHub projects, who's doing meetups about Neo4j and graph databases. These are all populated by lambdas that sort of fetch data from these different APIs periodically. And there's a GraphQL API that sits on top of that. So whenever you go to community.neo4j.com, it's sending a GraphQL request to populate the top of that page, fetching data from Neo4j, which I think is pretty neat. We built it last year, and it was pretty easy. Cool. So the next group using GRANDstack and Neo4j GraphQL that I want to talk about is the Financial Times. So the Financial Times you may be familiar with. They are a financial publication, and they use Neo4j in a few different ways, but this specific project that I'll talk about is known as the BizOps API. So they wrote a great blog post that talks about mostly performance testing when they decided to adopt this Neo4j GraphQL integration. You can see essentially the data model they have here, where they're connecting things like products to internal teams, the stakeholders for those teams. When something goes down, they know what products are going to be impacted. They know which teams support those, and they know who to call in the middle of the night to go fix it, essentially, along with a lot of other things. That's probably a simplification. So this is really neat because I think it shows how you can use GraphQL and GRANDstack to build not only these sort of applications that you're exposing externally, but also to build internal tooling as well. Reese from Financial Times, so Reese Evans, who's a principal engineer that works on this project, he gave a great talk which he calls a field guide to the Financial Times, where he sort of shows how they put this system together, and he sort of compares using GRANDstack to being, Mark Zuckerberg hacking something together, very, very productively, which I thought was an interesting comparison when we're talking about developer productivity, right? As we look back to things like LampStack and MeanStack and why they became really popular, I think it was really because they made it very easy for developers to get started building applications. So anyway, so that's kind of what I hope GRANDstack can be as well, making it really easy to build applications. And then the third GRANDstack Neo4j GraphQL user I want to talk about is Human Connection. So Human Connection is building a decentralized social network, essentially to try to bring about positive local and global changes. And they use Neo4j GraphQL and GRANDstack to power their decentralized social network. And they gave an online meetup a few months ago where they talk about some of the internals of that. And Robert and Greg have been great. They've submitted a few PRs to our GraphQL integration and done a lot to improve the documentation and sort of tell other people how this integration works, which has been great. And that's one thing that I really appreciate working with the GraphQL community is sort of the interest around this. Everyone I think who's involved with GraphQL sees the advantages and the benefits. And this is why Neo4j joined the GraphQL Foundation as a founding member earlier this year. So the GraphQL Foundation is essentially the stewards of GraphQL after it was open sourced by Facebook. So Facebook open sourced GraphQL, then handed it over to this foundation to sort of nurture and evolve GraphQL for the community. So at Neo4j, we think GraphQL is really, really important, and we're happy to support it by being a member of the GraphQL Foundation. So this is an online conference. All these videos, of course, are going to be available later on, but I just want to highlight some of the other GraphQL and GRANDstack related talks that we have coming up, which again, you can find just by playing around with this conference demo app. But after this, we have Michael, who's going to talk about exploring the US National Bridge Index. We talked about Pat Brown from Under Armour talking about how they use GraphQL and GRANDstack. Then we have some interesting data visualization things from Christian, who's going to show us how to do data visualization with GraphQL and GRANDstack as well. So if you find this session interesting, be sure to look for these other ones today, and also when the videos go live on YouTube. If you've used our GraphQL integrations and you'd like to give us some feedback to help us drive the development of them in the future, that would be great. I would really appreciate that. You can do that by going to grandstack.io/survey. There's a really quick one-page survey with lots of optional questions. So feel free to tell us, as much as you like. But that's really helpful because it lets us know what features we can invest in, how folks are using it as we move forward. I mentioned the grandstack.io site. There's also a blog where we publish sort of regular updates as we add new features, examples of how those work, and walkthroughs, things like that. So it's a Medium publication. You can subscribe to be notified of new posts on Medium. But grandstack.io is kind of the landing page for all of this. Okay, so we're a bit over time, and I'm sorry about that. But hopefully, if you're still with me here, we can jump in to the Hunger Games. So again, the Hunger Games. These are questions that we have at the end of each of these talks at the conference. And there's an online form, so r.neo4j.com/hunger-games. And you can submit your answers. And there are prizes to those who get the most answers correct. So for this one, you might want to take a screenshot now, so you have these questions later on if you want to do them later on throughout the day. But basically, the challenge here is to use the nodes 2019.grandstack.io. This links to the GraphQL Playground, which is the API for that conference web application that we looked at, and answer these questions by writing a GraphQL query against the API. So first of all, and again, this is all data about the schedule for the conference today. So first of all, what is the title of the first session when ordered by title in ascending order, right? So in alphabetical order, which is the first session. Which speakers are presenting talks about Kafka? And if I like the talk about NeoVis, what's the top recommendation for me? Maybe since, as a reward here, I guess, for sticking with me to the end here, maybe we'll just take a look at the answers here. So I'm going to jump over to GraphQL Playground. And again, this is available just at nodes 2019.grandstack.io. So the first question here is, what is the title of the first session when ordered by title in ascending order? Okay, so I can look here at my documentation for the API. I want sessions. So let's clear out the query we had in here before. And we'll start at the session entry point. And I just am going to grab the name here because that's all I'm really interested in to answer this. And it says ordered by title in ascending order. Well, we get this nice autocomplete here that tells us that we can pass an order by arguments here. And we even get this nice completion here for the arguments of the order by. And in this case, we want to order by name in ascending order and return just the name of the session. And the first in alphabetical order is APOC Pearls, best tips and tricks. So it looks like the answer to that is A. Cool, now the next one, which speakers are presenting talks about Kafka? Okay, so I think we can still start with the session. If we jump to our docs here, we can see from the session, we have a field called speakers. So this lets me know I can traverse from the session to the speaker. So we're going to want to go to speakers and grab the name of the speaker, but we're only interested in talks about Kafka. So let's do a filter. So I mentioned earlier that our integration adds these nice filter arguments. So let's filter for where the description contains Kafka. Let's see what we come back with. And we get back 2 talks. So building a full stack fraud detection solution with Kafka, GraphQL, and Neo4j graph algorithms by Mark Needham, and streaming graph data with Kafka by Andrea. And if we go back and look at our options, looks like that is option B. Okay, and our final question here, if I like the talk about Neo4j, what is the top recommendation for me? Okay, so first we need to find a talk about Neo4j. So maybe let's take out our filter there and let's search for where the name, so in this case this is the name of the talk, contains Neo4j. Let's see if we can find that. And yep, we get back leveraging graph algorithms and visualizations with Neo4j, which is a session I'm presenting later today. And we said we want the recommended sessions. So this is, remember, that cipher directive field where we said the result of this field is going to be determined not just by traversing the graph and fetching that data, but by running a more complex cipher query. So we're generating our personalized recommendation here. So if I like this Neo4j talk, what talks am I going to like also? And let's go ahead and grab the first 3 here. So when you run that, remember we're using the score to rank these. So these are scored recommendations. So the first one is graph visualization, main aspects, challenges and solutions, large scale social networks, challenges and opportunities, and discovering the soul of a product with Neo4j. Cool, so graph visualization, main aspects, challenges and solutions is the top recommendation. So that looks like A. Great, so thanks a lot for coming to Nodes today. This is, again, just one of the sessions. There's a lot more content waiting for you at neo4j.com/online summit. The slides for this talk are available at bit.ly/GRANDstack. And important to note that the grand is capitalized in that. I'm not sure what _GRANDstack will send you to, but not these slides. And if you're attending Nodes, be sure to try out the Nodes 2019-app.grandstack.io to search for sessions that you might be interested in and just sort of see some recommendations powered by GRANDstack.